Hoy hoy, and welcome back to the labs in a new location. We're testing out some of the YouTube functionality as we're trying to get our platform working across, multiple systems. We also have been testing a lot of different things. But the other cool part about that is it's kind of given our chances in at least two classes now to kind of show the differences and things that we've liked about the different platforms and classes. But during one of those classes, another Python class, similar to what we're going to be doing here, I was kind of trying to think of where would be a good place to begin and kind of start thinking about it. There was a lot of kind of history, programming theory, concepts, and stuff in the other class. And here I kind of want to jump right in. So we're going to be developing a poker game, mainly because it's something that it's very familiar to a lot of people, especially American audiences, and it's something that has a lot of variation. There's things that you can have little rules to change. If you're using wild cards, if you're playing, against a dealer versus if you're playing a standard table against friends, things like that, and that gives us some opportunity to kind of play around with those ideas with classes that kind of make sense. Like, if I was doing some programming class for some architecture, it might be, server handler, whatever. And to somebody who's new to Python, that might not be obvious at first. Like, it's not the first thing they're going to think of when it's like, okay, this is some server, this is what it's handling. It takes some time to get familiar with a lot of those APIs. So, starting with this, I'm hoping that it's a good platform to just dive in and start scripting some stuff in Python. The other thing I wanted to point out, this came from something that brought up in one of my classes, is, and I don't know how to say the name, it is right here in the browser window, Replit. I don't know if it's Replit or how you're supposed to pronounce that, but I really like the website for being able to test stuff in Python, especially Python 3. There isn't much that kind of uses Python 3 at the moment in development, in my experience, though I know more and more is starting to, so it's kind of a great way to test stuff, test compatibility, and just kind of make sure it works in a nice, simple interface. When you first start it up, this is what you get. On the right hand side, this is our interactive interpreter. This will allow us to import things, run stuff, test different commands in Python. This middle section is the file we're going to be writing in. By default, it just says main, that is the name, main.py would be the file name if you're saving this in Windows, on OS X, or any operating system. So this is just a little file browser independent of your computer for scripting and testing things. And up here is the name, so this is the location. Right now it's just kind of anonymously stored. No description, and it doesn't really have much of a name. By default, it just gives you a custom name. So while Prudent Disguised Ampersand sounds like an awesome project, let's totally name this something. Oh, okay, yeah. I'm only going to be doing the stuff I can do with the free demo stuff. So I'm not going to be doing full login stuff, but we're going to be able to test our examples and work with the code in here. So the first thing we're going to need is cards. And we need to think of not just what is in a card, but what cards we're needing specifically for a poker game, a standard 52 deck. Yes, 52. We're not adding jokers right now, but there's ways we can add jokers, and hopefully we can get to that shortly. This is also going to be a running series, so while I don't know exactly where this session's going to end, the end of this series we're going to compile all of the videos and source material into one video that kind of goes from beginning to end of building the poker series. So don't fret if you're missing individual parts or anything. Just feel welcome to jump in. And yeah, we have our communities both on YouTube. Actually, both. We have three now. YouTube, Facebook, and Reddit, which is just starting up. And the website has just been rebuilt. If people want to check that out, help contribute in any way, that would be awesome. But yeah, let's start with these cards. And with a card, it's like we need to figure out like what values and things we want to have. So if we're trying to say the value of a card, let's just test, how we would set that. We need to set a variable. Python, it's really easy. You don't have to have some set keyword. You don't have to have the return type keyword like init or bool. It will try to figure all this stuff out on the fly, which tends to be a little slower in runtime applications, but it's really fast to develop in. And there's ways to kind of beat the runtime aspect of that as well. We won't be going into that in this series, but there are things like not CPython, Cython. However they pronounce the difference between them. CPython is what Python's built on. And then there's an export to see things like that, as I said. We won't be going into that stuff directly as much. But if we're saying this value, say, the value of our card is 3. Cool. We got nothing in response to that. But if you go in and type value, now it will return 3. We have successfully set our first variable in Python. It's pretty straightforward. But what if it's something that's not as simple as an int? What if we're storing something like a floating point value, which is just a number dot something, negative or positive? If you're saying like 3.14 yada yada, that would be a float. While you wouldn't be able to have the entire string because that's a irrational number or entire float value string. Not sure the quite correct terminology on that. I'm sure somebody's going to correct me and it'll be fixed at some point. But you can't have that entire thing on there. And there are little systems and tricks. You can actually use a pi value, which is a really good approximation in Python. But things like that, it's always good if you're needing to use them for verification or anything like that. To double check, have ways that you can error correct if you need very small or very large numbers. But it's the same thing if we're trying to store it like this. It's just 3.3. Same thing, type value again, check it. We now have a floating point value. Anything like a string, let's say suit would be a good name for this. It's going to be a spade. The only real difference is I had to use quotes. One of the things I will point out is I tend to use double quotes when I'm using something literally as a string versus a value or something. This is a stylistic choice. If you notice in here, Python is kind of loose when it comes to its spec on which one you should use. They're fairly interchangeable. The one time that it does become really important is when you're trying to nest quotes. So if you're trying to say, somebody was saying that they said this, grammatically correct, of course, that's when you would use those nested quotes in English. You can use the same thing in Python. So if we were saying, suit equals, let's see what I'm typing on again. Suit equals king. This is totally an arbitrary example. But now if I go to suit, you'll see that it actually stored those quotes. There's ways to escape them. We're not going to get into that until we run into it really in this course. But from here you can see we have a lot of the basic values we're going to need. So storing those is pretty simple. But now how do we combine all of that together? How do we make it an object that has these different values? And that's where classes come into play in Python. So aside from the interactive interpreter side of Python, you're going to see a lot of Py files, and in there you're going to see defs and classes. Defs is defining a function, so think of those as just your functions, your methods, the things you're actually running to do specific commands. When you're thinking classes in Python, think the objects themselves. So the individual things in there, the variables, would be the description, say, of a football. The football would be the object, and then within there would be things of, the texture, the color, the individual attributes of that object. And then there might be some methods on there like inflate the football, deflate the football, things like that. That's where my example kind of broke down. I wasn't thinking that far ahead on that one. So if we're trying to create that here, let's just create a very simple class. So start with a keyword class, and there's only a few really important keywords in Python. Everything else is importable and fairly malleable when it comes to name. Class and def are two really important ones. So we're going to go over a couple of the ones that are just the need to knows of Python pretty early on. So I'll just point them out when we get to them. Class is totally one of them. And I'm just going to capitalize the name of card for us, just because I like the naming convention where classes are capitalized. Makes it easier to tell in the code between classes and functions, in my opinion. But as I said, there's a lot of different opinions on this, so the big thing to pay attention to when it comes to a coding style is match the code you're in. If you're working in a specific environment, say a company, and everyone codes a certain way but you, that's kind of a problem. And same thing is if you're trying to build a community, it's trying to get that common document wherever that common ground is to kind of end up. But I'm going to just stick with the one that I know and kind of promote my own stuff. We won't really be going into that stuff in this class. However, it's one that I'm sure I'm going to get to at one point or another. And right here is what you put, where you put what you're going to base your class off of. So right now, a card isn't really based off of anything, but you can still give it a base object, so Python knows, the standards, how to use it, how to work with it, and the keyword for that is just object. Pretty straightforward at this point. You don't need to worry about semicolons or anything like that ending your lines like you do in a lot of languages. But this first one, since we're defining something, which can be, as I said, function, class, method, or for loops and things like that, you end with a colon. So it's just one of those, you need to know when to use your colons. This is, the first example of that. And then from in here, we just have a class. There's nothing to it. If we just put pass right there, this will run and function and do absolutely nothing. But we have successfully created a nothing at this point. So from here, we want to start defining something in this class. One of the first things I'm going to start defining is just the init method. And this is, as I said, we're going to hit a couple of these pretty early on, where those you just need to know in Pythons. But there's a set of magic methods that if you add to classes, they change how things function automatically. And it is one of those. It's when you initialize any class, what are the default attributes, defaults of that object you're going to give it. So we could think of like a football is going to be standard football color. Yeah, you could have a blue one, but that's not going to be the standard. So from here, let's just add that def init. And you can tell a lot of those magic methods, because in Python they'll have these what are called dunders. I always thought that was kind of a fun name anyway. But it's a double underscore, and just makes it pretty clear when you're going to run into those. You can create your own. I mean, Python's very flexible in naming. The one thing is you can also code yourself into a corner really easily because of that. Because you can use up a name that you need to use for an import or something else, and then you have to work around that. So just kind of be cognizant of that. But if you're intentionally overriding these, perfect. That's what they're for. With classes, the init is one of those you just have to know how to work with it to really build a class. And it's just what runs automatically anytime you build a class. So let's give it its init. Now that we're inside the class, though, any function we want it to be aware of, where it has to be able to use itself or be aware of itself, we have to pass in self as that first keyword. Oop, not a semicolon. We don't need those in this language. Cool. So we have our init, and same thing if we pass right there. We now have a functioning object with a functioning beginning that does nothing. Now we need to figure out, okay, what are the key things we need in our card? There needs to be a value. We need to have a suit. And do we really need anything else at this point? I'm trying to think of that. In the other example in the class, and this is totally the fast-forwarded crash course version of this, we totally used images and other things. But for right now, I think that's totally going to be fine. As you can see, Python will try to allow space and line breaks across commas and things like that. This website's pretty good about that, but I might also shrink that down a little bit to try keeping it on the screen. I'll keep going, see how it holds up at the moment. But yeah, so value and suit are going to be our big ones. And if we want the card to be able to, just ask at any point, if somebody can ask, hey, what is that card's value? And they should know, or on any object. But yeah, in this case, we want to be able to do that for the card. This is where you need to be able to set extra attributes. So let's just do this for now. For the final version of this, I'm actually going to do some encryption and stuff on this, because you should be able to control who knows and how they have access to that information. Because if I'm sitting across from you at a poker table, yeah, it would be helpful for me to be able to see your cards, but it kind of breaks the game a little bit. So yeah, we'll get into that one. But for right now, we're going to just keep the cards private. So we'll add our self.value and our self.suit. And to transfer these over, it's really that simple. So now, if we run this, so that's saved. That's updated. Now let's just see. Cool, so we have a card. If we do... Oh. I did value, then suit. So 3 of hearts. And I should probably save this card, so I'm just going to call it card for now. I know, great naming convention. Now if I ask for card, boom, I have something that gives me nothing useful looking. We'll fix that in a second. But we can also go card.value and hopefully get a number back. So we still have our 3 of hearts in there, but what is this gibberish? What this gibberish is it's basically saying this is coming from main of card object, and then it gives you the memory address. That information is, lack of a better word, utterly useless even for developers. That's something that's just never really going to be important. I was assuming at some point there'd be some great epiphany when I was a developer that could be useful, and in Python it just isn't. Other languages it can be, so good to keep note of. But let's go back to here and let's fix that, because that just doesn't seem friendly. So this is where we'll have to add our second one of these magic methods. And this one is called repr. And this is, simply put, how it's represented. One of the things in Python is there should be one and only one obvious way to do it. But, it might not be obvious at first unless you're Dutch. Repr is kind of one of those, where it's like, once you see it, it's like, oh, that totally makes sense what that means. But, yeah, until somebody explained that, I thought that was just some voodoo code that I had to add in there. But what it does is, from here, we can now say, repr, let's return a string version of self.value. Wow, did I mistype that spectacularly. Self.value and self.suit. Oh. Yeah, I guess we have to add some stuff. So plus space of, need to add actual spaces there. And then let's just add suit directly, because suit's probably already going to be a string at this point. So now that we have that, let's see if I can... Sweet, okay. That makes this a little easier for us to see. From here, same thing. Let's kick that over. And now card equals card. 3 of hearts. Though you realize right now there is no limit to what this suit could be. We're going to automate that part in another step. 3 of hearts. Now if we type card, process died. Oh yeah. Yeah. That could be a problem. This was an important thing. I should actually go back to that. What the problem was in here, I'm using, you can see here, self.value, because this is something that was passed between these functions. And that's what this class enables us to do, is pass information across that self object between all the different functions, which gives it a lot of power. But in this case, it has no concept of what suit is. Suit is for this function. So when I got down here and said, give me suit, it was just like, what suit? And here you can just say self.suit. And now let's try this. This should actually work a little better. Meaning it should hopefully work at all. Bam. Card is not defined. What did I break? Oh, no, that should be right. That should be good. That should be good. Let's test this again. Okay. So, I don't know what I did on that one, but let's just go for the best on this one. 3 hearts. Bam. Now if we look at the card, it tells us it's the 3 of hearts. So we can fix that up a little more, have it tell us that this is a card and it is the 3 of hearts, and we can make that a little nicer. But now it's a little better than just a raw memory address, which, as you saw, was kind of useless. So now we have a very basic card. But how do we get a deck? Now we need to actually create a deck of cards. So let's get to that part next. I'm going to take a drag off this and mute myself for a second so I don't... Darth Vader. In my other stream, somebody always commented that I sounded like Darth Vader occasionally. It's like, is that like a breathing machine? Something like that. It's like, yeah, it totally helps me breathe. No, it's totally a vape. But, hey, at least people remember that I sounded like Darth Vader once every like 5 minutes. Let's see. So we have our value, we have our suit. So now, let's create a deck. And a deck is going to be really simple in our case. But same thing, let's create class, call it a deck, put an object into it. But actually, let's change that object. So one of the things in Python that's a default data type that'll be really handy here is called a list. So, lack of names, this is going to be list Bob. And Bob is going to have 3 children named Cody, Tom, and Mary. So now if I run that, go back to Bob, you can see, boom, I have a list. So now we can see what all of these cards are. So if you take a look at it, you can see that it's like, okay, yeah, Tom, Mary, all that stuff. Cool. So now we come back over here, we create something off of that list. We can put list here. Now deck is a list. So if we do def init, let's just give it self again. And really, I guess one note on self, that is a style thing. The word self is irrelevant. It can be anything you want, but that first variable always has to be that class variable. So that's something to keep in mind when you're writing functions inside of classes. And no, I did not mean to do both those inside of that. Thank you, random voice on the internet. Yay, modern technology, right? It's like in previous class, you'd be like sitting there like messing with that for like 5 minutes and be like, I don't know why that is. And cut that video part out later. And it's just like, and this part magically fixed itself once I realized I forgot a semicolon. Not saying that, that's happened time and time again. So, now we're inheriting from that list. Let's actually turn this into standard deck. We don't really need to separate the two at the moment. And it'll be a list. And here in the init, let's add a couple of these lists as well. Suits is going to be an important one. We have hearts, spades. Whoop, comma needs to be in the right place or that would not work. Diamonds. And clubs. That's the other one. Thank you. Yeah, poker. It's so common. Everyone knows it. Wait, what is that part again? Yep. Let's see. That's the opposite direction I was trying to go. There it goes. Can I make this fit a little better? Is that better for you guys? Cool. Trying to get everything to fit on screen is always a challenge. So, any critiques, totally appreciated. So cool. So now we have our suits. Now we need our values. And this is where it's going to get a little interesting because we don't just have a single value per se. We have a face card value and we have a numeric value. So we need to have something in there that indicates, if it's a face card or not, more or less. And if what its value would be kind of respective to that anyway. So like we can add some extra functions when we create our standard deck to change a couple variables, and I'll get into that. But here we're going to need values. Let's see. We don't have a 1 card, but we do have a 2, 3, 4, 5, 6, 7, 8, 9, 10. But we also have the 11, the jack, the 12, the queen, and 13, king. Is 13 right? And then 14 would be ace, right? Okay. So let me go through this in my head again. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 10, jack, queen, king, ace in our case. So we have that. I'll actually do a quick Google on that. Ace as 1 in straight poker. May indeed be used as a low in straight. So that is good to know. We'll definitely have to get into that. But essentially that means an ace can be a 1 or a high card in this case. Right now we can totally use it like this, we'll have to add an exception for it, because more likely it is going to be used as the high card than the low card, though there is one specific hand for us to worry about that on. As I said, awesome to have live people. So we have our values, and here we also can give our, do we want to give names right there? Actually, let's change this. I'm going to add this into a different data type to make this a little easier to see, because this is going to be two sets of data, and we're going to need to give them a name anyway. There's going to have to be like a jack of something. So let's make this a little fancier and have some fun with this, right? So from here, let's turn this into a dictionary. And right now I just broke the code. But I'll do a quick demo of a dictionary. Oh no, I'll fix this first. So with a dictionary, essentially it's kind of like the term sounds. Everything has a key and a value. It has their name, Dorothy McMinnville, and then their number. Well, just like, or I guess that's a phone book. Dictionary has a word and then its definition. But you kind of see how there's a key and value pair there. A dictionary in Python is no different. In here, let's give this a value of 2. And then you can kind of see I'm going to continue this here. But what I want to do, because now this will be a little more data, now I can just start breaking these up. I know, real-time programming isn't the most entertaining. Oh. Yeah, no one corrected me on that one. That was totally, not the card we meant. Cool, so now you can see we have suits, and then a big dictionary of values that we want here. So now we can start combining these. So in here, come back in, That looks like I'm on the right line. And for, let's see. And I guess we could do this either way. We can go by suit and create the values for them, or values create the suits for them. But essentially, we're going to have to nest this loop. So it's just nest this loop for value in values. Value is my new variable, but as you see, I'm trying to keep it as simple as possible. So in here, we're going to have our value key and value value. Let's do here for suit in suits. Self, because remember, self is a list, dot append, a method on lists, things that you can append to, you can add to them. So we're just adding to the end of this list each card with this suit and value set. And from here, we should be able to add a card object, which now, because we added another value here, let's do our name value in suit. So our name will be value, which is kind of confusing. So let's fix this here. Name in values we have our name. That makes this a little more confusing, this a little less confusing, but meh. Values. Look up name into that. That should be the value for that, and then I need the suit. So now we're going to, while we go through both these loops, create a card, and then loop through card, 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 with the name coming from here, the value, which is by putting the name back into the values dictionary, essentially looking it up like a key dictionary pair, or phone book pairs, I tend to think of them. And then the suit, which we're iterating through the suits right there. So now, since that's in the init, we should be able to run this. We'll see how bad this crashes. Deck will be dun da 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 standard deck. Cool. And there we go. So now we have a standard deck, and it looks kind of useless. Let's also look at what I did with the names, because we have a 14 of diamonds. So let's fix that quickly. We have our name, our value. We need to add this here. Self.name equals name. And then down here, we just change that to name. And I just did Control S, like that was going to do something here. Now we can go to deck. Bam! That seems to make a little more sense. For a card in deck, print, and since we're in Python 3, this is a function, card. That should work. What did I do wrong there? For a card in deck, print. I'm not sure how to do a for loop live in one of these, so let's see. Print. There we go. Now it's all in a list. But as you can see, we're coming into dun 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 issue number 2 with creating this. Is there is no randomization whatsoever. I would say this might be a step worse than if they were all in like 1, 2, 3, 4, 5, 6 order. As you get like a brand new deck, but you can't use a brand new deck directly. You have to shuffle that deck. So that's where we're going to start importing our first Python set. And I actually think we would be able to do this a little more directly. Let me do a quick sanity check. Here, boom, that's creating something. I'm going to see if Python 3 has a built-in shuffle. I don't know if it has one in ToList, but okay, that's not very bad. So this is going to be a pseudo-random at the moment. We will fix a lot of the randomization and encryption stuff a little farther along in this. For right now, as I said, the big part is just to get as many people in familiar with these concepts. So just diving in, I'm going to be importing another class. And what this does is allows me to, if I save my own functions, other people could import them. This allows me to import code from other libraries. Just kind of handy to be able to, import, share code around like that. But the one I'm going to be looking for is random. And specifically, I want random shuffle. So let's test shuffle really quick over here. Import random. Random.shuffle. And let's give this a random list and see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Let's see what that does. Did that return anything? This might not return anything. So yeah, things like this, they might feel kind of frustrating. What they're doing is they're actually manipulating the object that's handed to them. So if we make x 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Boom. Now if we do random.shuffle x, let's look at x again. X is now shuffled. So that actually kind of helps us quite a bit here. One of the things about this is it's not a random shuffle. We can get into that. It's not so much that it won't feel random in any one usage, because that's what this random package is really intended to do. The thing is, though, if you run it enough times and you know when the device started, you can start to figure out patterns. So it's not cryptographically secure enough for something like a Vegas machine or something like that. But for right now, we're just going to start with random, and then in here, our deck, let's just add a shuffle function to this. And that's as easy as coming back here, make sure I'm on the right line. I can't see what one I'm on. Okay, so def, shuffle. Same thing, we're in the class, have to give it self. And let's actually give it a random variable here. Number of times. Let's just say times, because that totally makes sense. And its 1 is just going to be 1. So, or its base value is going to be 1. This will be, you shuffle the deck once. So from here, we can do random. Oop. Dot. Oop. Shuffle. Self. I'm actually curious if this is going to work. That might actually break, but let's try that here. What happened to my deck? There's my deck. Cool. Deck dot shuffle. We'll see what happens. Now let's look at deck. Okay, let's see. 2, 2, 2, 3, 3, 3, yada, 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 yada. And that didn't do anything. So what we have to do here is we have to essentially take those values out and put them back in with this shuffle. So let's say x equals actually let's think on this quickly. Let's change this a little bit. Let's go back to an object. Let's make these cards. So let's see. Self.cards equals nothing. Basically an empty list. And then down here, self.cards.append. So now let's try this down here where we have self.cards. Let's see if that works any better. So we have our standard deck, we have our shuffle. See if that shuffles. Then call our deck. So deck. Print I. Standard deck is not iterable. Okay, so we are going the other direction on this. Let's see how I can do this. And this is one of the other fun parts when Python programming or developing anything really. It's like you run into these little roadblocks in languages and stuff. It's like, okay, what is that? It dawns on you, but being willing to Google something is actually a positive in, I would say, any industry, but especially programming. Being able to, know what resources are available from Stack Overflow, the Python page, books, other resources, people, forums. But yeah, let's dig into this one again. So, deck.cards is now all mixed up. Okay. So that is totally working now. Let's see what we can do to make this a little easier. Let's just put a print in here to make it clear when it's shuffled, deck shuffled. And we're going to have to come in here and define a little more what we're going to do for here, because yeah, we don't want to be able to just look through the cards. That's kind of an interesting oversight I wasn't thinking of until now. But we do want to be able to essentially shuffle and pop those cards. So let's just up here, in each card, let's give this a value. Self dot face up. Or let's see this. I don't like ones that you have to define what the definition is in it. So is it showing? And by default, false. In here, we can do an if showing. Do one thing. Else, return card. Run. Here's my standard deck. Ah, yes, that would break things. Remember those pesky selfs. See? Now all the cards are face down, so we have a deck of cards, and you're saying, what's in this deck? They're all just going to say card. This also gives us an interesting way to see if something has already been through the deck. Because in the discard pile, theoretically, all the cards should, well, I guess they wouldn't all be face up because some of them discard face down and poker rules, things like that. But now you can actually have that differentiation. So it also means that you can have that information available to the player of what cards have been shown or not. This is something I've been kind of playing around with, but right now, this is kind of a cool way to see, what this is. Let's figure out a good thing for deck, though, because if we just do deck right now, we get that memory object again. Not very useful. Let's go into here, and now that we have a shuffle, let's also add our, well, I guess, coding convention. I should add it up here. Def, grepper again, and here I just want to be a very simple return. Let's see. standard deck of cards. I'll add the slash in for a new line. And here's where I'll get into a new function. So what this \n is, think of that as one character. That is a new line in a piece of text. So that's going to be kind of useful there. But this other part is squiggly braces with a 0 in it, and then cards remaining. The squiggly braces indicate that I'm going to be using formatting. And from here, I can just do .format and choose what I want to go in there. But what I want is going to be another function, the len of self.cards. So now that will, theoretically, let's test this theory, deck totally returns with that slash in the middle. Let's see. Let's format this a little different then. This way I don't have to recode it. It's like being lazy, but winning. So, standard deck of cards, 52 cards. And if you went, like deck 0 right now, it's not going to let you index them intentionally. That's something that we're going to play around with. But I am going to make some things into shuffle so we can do some cutting and other things later. But yeah, that's going to come a little later. We're getting close to our first hour, but from here we have cards. We have a standard deck of cards using this that has shuffle. And right now, shuffle is really the only function we have. Kind of good to know. But from down here, let's add another one. What's the last thing we need from a standard deck of cards? You can, get the cards, you can create them, you can shuffle them. Well, the last thing we need is to be able to deal them. So, same thing in this deck of cards. Let's come down here, make sure I'm on the right line, all that fun stuff, and add a function called deal. So we have shuffle and deal. From here, deal self, and what we're going to do is look up pop, and I'll just show you a quick way to do this on Python, on Googling list pop. And I just want to make sure I have the variables, all that stuff right. Go into data structures. And these are the things you can do on a list. These are just the default methods. And it's also good, as I said, I wanted to show some needing to dive into the documentation. I've been using Python for a while, so there's not much I'm really needing to dive into documentation for at this point. But it's good to know where it is, to know your resources well. I've read this website so many times. I probably know the structure of it in my head. But yeah, so here's some of the things we want to look at. Appending is adding to it. We've already done that. Extending is you have two lists, you're combining them together. Insert, you're putting something in the middle of a list. Remove, you're saying, oh, remove this item from a list. Pop is kind of an interesting one. So you give it a value or not, and it returns an item from the list. And that means that it takes it from the list and gives it to you. So this is going to be the most useful in our deal situation. There are things like indexing, counts the number of times it appears. This will be useful, but we're going to need to define something for count to come up. Sort is also fairly useful, but sort will come in a little more handy a little later, especially going between dictionaries and lists if you need alphabetical order. And then reversing, this is going to be a great little feature for hands and things like that. So right now we're wanting to see the examples. Up there it just showed you the codes and methods. Can seem kind of daunting. Down here, I love the Python examples because they just show you quickly. This is what this function does. Here's our list. We did this. This happened. If we're wanting to come down here and see what's happening with pop, it's like, oh yeah, this is our thing. Pop, we took the last thing from the list. Pop, the last thing from the list. So that means that if we're wanting to do pop here, we'll have to do a pop on 0. And that's good to know, but as I said, fairly straightforward. So here what we'll have to do is self.cards.pop. We give that our 0. And then return card. So that should be pretty straightforward. Let's run this, make sure I didn't royally mess something up. I'm capable of that. So deck.deal. And let's give this thing. We don't really have a player at the moment, so this will be our rando card. Rando card equals deck deal. Boom. Rando. Oh, I was totally hoping that would have an autocomplete. Rando card. We have a card. Rando card dot showing equals true. Rando card is now the 2 of hearts. So I got dealt a random card. Let's try this again just to make sure. Oh, actually, no, I didn't get dealt a random card. Let's try this again. So let's go to our thing. Create a standard deck. Deck.shuffle. Deck shuffled. Now, rando card. Deck.deal. Now we should have a rando card. That, if we take our rando card and make it showing, we now have a 10 of diamonds. We now have a random card from a shuffled deck. So that's pretty good. We are able to get all that and very close to our hour time slot. Yeah, thank you everyone for jumping in, stuff like that. Awesome as always. We're going to be continuing this and then slicing up the videos, making a more condensed lesson, all that fun stuff. But yeah, in the meantime, if you guys like what you saw, feel free to jump in and support us on either the Patreon, the Streamlabs page, or just jump into the community, have fun with the Reddit and Facebook pages. And I'm going to be trying to get more of this code up and online. I'm going to get the asset library going. This is going to be one of the first things for that. So as I sign off, get ready for that. You guys have fun. I'll see you guys later. Peace.